I want to talk a little bit about power in context of electrical energy. So power, energy and work basically. So we know that energy or work has the unit of joule. So power we say is defined by the work done per unit time or energy absorbed or supplied per unit time. So we can say power is work done or energy absorbed or supplied per unit time. Now dW over dt. Now we want to correlate power with current and voltage, electrical current and voltage. So if we want to do that, what we can write is, we can write dW over dq. If we recall, this is the work done per unit charge to move a unit charge from one position to another position. What's the work done? That is the definition of voltage. And then dq over dt. So basically just writing the differential in terms of in this way. So this one is our voltage by definition, because that's the amount of work done to move a unit charge from one position to another position. So this is V, and this is of course I, the amount of charge passing through a cross section per unit time. So this is Vi. So we get P is equal to Vi. This one we should call that this is instantaneous power, because it changes with time. Whatever V is at a certain time and I is at a certain time, is the product of that is the power at that time. So we can say this is instantaneous power. So power will be negative or positive depending whether the power is supplied power. If it is supplied, we say that's negative, and if it is power is absorbed, then we say it's positive. So it goes something like this. Let's say this is a device. It can be an active device or a passive device. By active device we mean an electromotive force, a battery or something like that. A passive device can be a resistor. So if the potential of the voltage drop is like this and the current is like this, then we have current I here and V here, and positive voltage drop is in this direction, of course in the direction of current in this case. So that becomes V is positive, I is positive, so P is positive here. That means this is power absorbed. For a passive device, that is kind of resistor, this will be the direction of current where the voltage drop, in the same direction the voltage drop happens. If we call it drop when the voltage is in this direction. Now let's take another scenario where, let's say again like that, but the current is going in that direction. So the voltage drop is in this direction, the drop is in this direction, and the EMF, if we talk about EMF, electromotive force, that is of course in that direction, and current is also in this direction. That means in this particular case we can see that current is coming out of the battery. If that source is a battery, that means power is supplied. So if we say V is positive in the direction of voltage, then we can say either V is negative and I is positive, or we can think it otherwise, I is negative, depending whichever the nomenclature, whichever direction we think to be positive or negative. So what I will do is, if we go in this direction, we can say the voltage is in terms of current direction, the voltage, I will keep this lowercase. So in terms of in terms of the direction of the current, we can say the voltage drop direction is negative, because drop is happening in the other direction. So basically if we go that way, so I and minus V, so power is negative VI. That means this is power supplied. So this is how we can assign a sign to the power to say whether it's positive and negative. And for any circuit, a complete circuit where there will be a battery, let's say an EMF, there are some resistors, there can be some other passive elements, doesn't matter, we will have a scenario where this has to be power supplied. so PS, and this, all these have to be power absorbed, PA1, PA2, PA3, PA4, and then PA5. And what has to happen essentially for conservation of energy, that PS will be equal to all these PAs, sum of all those PAs. So maybe I from 1 to 5. Yeah, PA is from 1 to 5 basically. I don't know. AI if I say, so I from 1 to 5, yeah. So that's what it has to be for conservation of energy. And again, if we think in terms of current, the current will be obviously in this direction, because the from the battery the current will come out. So in all these sources, all these registers, current will be flowing in the direction of voltage drop. So all of those, if we want to say in terms of positive and negative, all of these will be positive power, so they are absorbing, power is being absorbed in these registers. And here the current will be in this direction, so if we say the voltage drop should have been, or voltage drop is in that direction, so the EMF will be negative, like that, if we want to say like that, as we want, if we want to assign power to power as a sign, then this one will be negative. So all these PAs will be positives, and then PS will be negative, and the sum will be 0. So, but let's not get confused about this. We can assign power and sign, usually that's done, and the supplied power is negative, absorbed power is positive. But the thing is that we have to just know which is absorbed and which is supplied. So we can write one in one side of the equation, the supplied one, and on the other side we can write the absorbed ones. So that should be good. So yeah, it's just an introduction to the concept of power.